Hello students, welcome to chemistry classes. So I hope all you are learn about this periodic classification part 1. Today we are going to discuss the continuation of lesson 3, classification of elements and periodicity and properties. So up to we are discussed the Mendeleev periodic law as well as some salient features of the Mendeleev periodic law. So the Mendeleev periodic law or Mendeleev periodic table also having some demerits. To rectify the limitations of this Mendeleev periodic table, the long form of periodic table is maintained. Long form of periodic table. Long form of periodic table or the modern periodic table is based on modern periodic law. Henry Moseley is a scientist proposed the modern periodic law. So up to which the scientist tried to arrange the elements based on their atomic weights. Instead of atomic weight, Henry Moseley proposed the table based on atomic number. So in his experiment, he plotted square root of frequencies emitted by the various elements. Square root of frequencies emitted by various elements versus atomic number of particular elements. So in this graph, he got a straight line. The same type of straight line not obtained in the case of square root of frequencies of elements versus their atomic weights. Therefore, the Henry Moseley is arranged the element. Is the only way to arrange the elements in the particular order is must based on atomic number, not based on atomic weight. And he proposed one law called modern periodic law. Modern periodic law. So what is modern periodic law or state modern periodic law? It is a simple 2-mark question. In the examination point of view, it is important. The physical and chemical properties of the elements of their atomic number. So simple rule. Physical and chemical properties of the elements of their atomic number. And the long form of periodic table was developed by the scientist called Bohr's. This is a Bohr's table, but the law only proposed by Henry Moseley. I already told you in the previous classes, the groups, the 18 groups are designated by the numbers like 1A, 1B, etc. To avoid confusion, this old terminology is replaced by modern terminology. In the case of modern periodic table, the numbers starting from Indo-Arabic number up to 1 to 18. 1 to 18. The group periods are numbered by 1 to 7. This is periods. 1 to 18. This is groups. The vertical columns and horizontal rows. Vertical columns and horizontal rows. So salient features of this modern periodic law. Totally 18 groups. The 18 groups numbered from 1 to 18 and 7 periods numbered from 1 to 7. Number of elements present in the long form of periodic table of each period. The first period consists of only 2 elements, that is hydrogen and helium. The atomic number 1 and atomic number 2. How to write the electronic configuration of these 2 elements? I already told you how to write the electronic configuration of elements. Hydrogen 1s1, so only 1 electron, This 1 represents the group period number, or it is said to be the principal quantum number. Principal quantum number. This 1 represents the electrons. This is the sub-energy level. Sub-energy level. What about the electronic configuration of helium? Helium atomic number 2, electronic configuration 1s2. Helium 1s2 is a very short period. The group number, so period number 1 is a very short period. Group number 2 and group number 3, each consists of 8 elements. 8 elements. This is boron, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silica, phosphorus, sulfur, chlorine and argon. So second and third period, each period consists of 8 elements each. These are known as short periods. Short period, first period is a very short period. The second and third period is a short period. How to write the electronic configuration of these elements? Let us consider second period. Second period starts from lithium, end with neon. Second period starts from 2s1, 2p6, end with 2p6, or simply say lithium atomic number 3. How to write the electronic configuration of lithium? 1s2, 2s1. 1s2 is the configuration of helium. Shortly it is written like this: helium 2s1. Beryllium atomic number 4, 1s2, 2s2, or shortly it is written as helium 2s2. Up to neon, neon atomic number 10, it is written like this: 1s2, 2s2, 2p6, or helium outer electronic configuration 2s2, 2p6. 2s2, 2p6 is the electronic configuration of second period. What about the third period? Similar way, third period. For example, sodium. Sodium atomic number 11, electronic configuration 1s2, 2s2, 2p6, 3s2. Up to this is the electronic configuration of neon. Therefore, shortly written like this: configuration of neon 3s1, 3s1. Sodium, electronic configuration of sodium, neon 3s1. Up to argon, chlorine, argon, the electronic configuration of argon 1s2, 2s2, 2p6, 3s2, 3p6, 3s2, 3p6. So this is the electronic configuration of argon. Fourth period consists of 18 elements. Fourth and fifth period. Fourth and fifth period consists of 18 elements. So this period consists of 18 elements. These are called as long periods. Long periods. 18 elements. These 18 elements, 2 elements in the S block, 10 elements in the D block, and 6 elements in P block. Fourth period and fifth period, each period consists of 18 elements each. These are further classified as 2 elements present in the S block, 10 elements present in the D block, 6 elements present in the P block. Sixth period and seventh period each consists of 32 elements. 32 elements. This is a complete period, this is the incomplete period. 32 elements, it's a very long period. The 7th period is the incomplete period. The 6th period, 14 elements are present in the bottom of the periodic table. They are called as inner transition elements. Inner transition elements. Inner transition elements. 7th period also 14 elements are present in the bottom of the periodic table. This is 4F block, this is 5F block. 4F block is called lanthanides and 5F block is called actinides. 4F block elements are called lanthanides, 5F block elements are called actinides. So this is the very long form of the present existing long form of periodic table. Is a Mendeleev periodic table, and finally this is long form of periodic table. Then how to write or pronounce the elements of atomic number greater than 100. First of all, you must know up to 88 elements, up to 88, only 88 to 90 elements are exist in the natural sources, or these elements are obtained from natural sources. After that, the atomic number 92 onwards, beyond the uranium series, the elements are man-made. The elements are synthesized in the laboratory. These elements shows small lifetime and their abundance also very low. These elements are identified by various scientists of various countries. They put their own names or their country names or some remembering names. To avoid confusion, the International Union of Pure and Applied Chemistry, IUPAC system of nomenclature gives certain rules and regulations how to write the name of the elements based on their numbers. For example, 100, it consists of 3 digits. The 1 is an, it is represented as an or uni. This is 0, it is represented as nil. So the symbol for this element, the first letters U, N, N. What is the symbol of atomic number 100? U, N, N. 0 means nil. 1 is an or uni. 2 bi. 3 tri. 4 quad. 5 pent. 6 kex. 7 sept. 8 oct. 9 en. 9 en. So suppose you are given one number, for example 117. What is the symbol and what is the name of the element? So this is number 1, therefore it is an. Number 1 an. 7 sept, end with IUM. What's the name of the element? Unseptium. 120 is the element. What is the symbol for this element? UBN. Un by nil. So name of the element is unbinilium. So you practice all the elements up to 120 or 130 in your home. You refer your text for more. If you have any doubts, you can ask. So you practice the first 4 pages or first 6 pages of this element, this lesson, that is classification of elements and periodicity and properties. Thank you.